Hello guys, thank you so much for being with me in the last machine learning tutorial video. This is our last discussion in this educational package. Recommender systems that have a wide commercial uses. You must have experience using sites like Amazon. After purchasing a product or service, users rate that product or service, and this collected information is used to recommend the products that each user likes. This was first started by Netflix. There are different approaches in this discussion. The group refinement approach is the most used and very simple. Many big sites like Amazon use it. There are some users who like a certain set of products. Now, if we can recognize the similarity of users' tastes, it will be very useful. In a situation where a user likes a product, if we know that another user already had a common taste with this user, probably this taste has not changed much, and the tastes will be similar even now. In a way, this method is a targeted advertisement. For example, the user Alice has bought 4 products and rated them, and has not bought the 5th one yet. In this matrix, rows are users and columns are products. This matrix is lonely. In the case of a site like Amazon, these lines can be hundreds of thousands lines, rows actually. Now, if you look at the elements of the matrix, many of them are unvalued. We can put 0 in their place. That is, the matrices are empty. What outputs we have from this matrix? An output is likely to be numerical estimates. We want to predict what this user Alice would likely rate this 5th product if she had purchased it. If this score is high, we recommend this product to Alice. Here 5 means the most interest and 1 means the least interest. We recommend a list of suggested products to Alice. We find the most similar users to Alice. The work is similar to the nearest neighbor algorithm. Then we look at, for example, among the other 4 users, user 2 is the most similar to Alice because they gave almost the same points to the products. Finally, we average the ratings given by users similar to Alice to the 5th product, which Alice has not yet purchased. If this score was high, we would recommend this product to Alice. There are different criteria to measure the similarity of users. On large business sites like Amazon, a number between 20 and 50 is a good number of similar users to consider. When comparing similarities based on users, we use Pearson's correlation coefficient. For example, the user Alice has a very different taste from the last user. The negative coefficient means that the tastes are opposite. Here we take a weighted average between the scores given by similar users to the last product. We can also use the cosine and the Euclidean methods to measure the similarity between users, but the Pearson coefficient has shown a better result. The common formula is to multiply the similarities in the points, sum their results, adding the results, and divide the final result by the similarities. We can also reduce the overall average here. Some people give good ratings in general, even if they don't like a product very much. Some people give bad ratings in general. even if they really like a product. The problem of this algorithm is that its matrix is very large and the calculation volume is high. This makes this algorithm very time consuming. This method is a non-parametric method. In these methods, we are always dealing with data. For each prediction, we need the entire matrix. These scores are constantly changing and updating. So if you use an offline model, you need to update the metrics. The periodicity of these updates depends on the type of site and the dynamic size of the scores. Before moving on the model-based methods, here we consider the similarity between users. This method is based on the user. Another method is product-based, where similarity between products is considered. We want to predict a score for Alice for item 5. We find products similar to this product. For example, the first product has received similar points from users. For measuring similarities between products as opposed to users, the cosine method works better. We calculate these similarities for all products and find the most similar products. Now that the first and fourth items are more similar, we need to calculate the points. We get a weighted average between the points that Alice gave to the first and fourth item. This cosine method has a drawback that it does not take into account these differences in scoring habits. To take this into account, we must also subtract the averages. With this formula, we calculate how likely user U is interested in product P. As I mentioned, this matrix is lonely, is empty. There is a problem called a cold start. When a user starts shopping and rating, we have no information about his or her taste. Over time, we learn his or her taste with ratings. The same goes for new products which no one has rated yet, and we don't know about and can't recommend it. This is the cold start issue. One solution is that the site forces the user to give a series of points when he or she at the first time enters at the site, so that he or she can get some information about give some information about his or her tastes. The second way is to use other recommendation methods in the starting moments or the default values can be used. These are non-parametric methods, but some methods are model-based. We only examine matrix decomposition here. Regarding matrix decomposition, we have already explained the SVD method. Which can be used to reduce the noise and compress the large matrix. The method of exploring communication rules, although it is old, is still used. Another method is probabilistic models. Probabilistic models are based on the mathematical foundation of machine learning, and AI giants believe that this may be the future of artificial intelligence. We will not talk about the prepayment fee, how can this model be updated regularly. This is an interesting discussion that many artificial intelligence master's students choose as a thesis topic. The goal is to free the large matrix, and we want to remove the redundant information. This SVD is also widely used in search engines and recommender systems. This is our data matrix. We said that the purpose of matrix decomposition is to find the three matrices whose product is the original matrix. These three matrices are U, which are our main vectors. Sigma is the matrix of single values. It is a diagonal matrix whose first element indicates the importance of the first vector, and the second indicates the importance of the second vectors, and so on until the end. We said that the first few elements of this matrix are big numbers, and this means that from one point on our vectors are not important and we can ignore them. We said these explanations in PCA only with the difference that here we decompose the X matrix itself and not the covariance matrix. These are our points matrix. We have given some examples of movies and some users. Some movies have a very romantic theme and some have a war theme, action theme actually. For example, the movie Titanic has a X1 feature of 0.9. That is, it is more romantic, but the movie Fast and Furious is completely about war. And now I have considered these two features. These features may be much more. We can learn how to calculate these features values. We can learn these features from this matrix. We want to learn a model for each user. Here users are the columns. We get a model for each task. Model means a vector. We need a coefficient theta 1 for x1. We need to learn a coefficient theta 2 for x2, and we need to learn a bias. So we have to learn 3 parameters for any task. Suppose we learn these parameters. We can tell that Alice is interested in romantic movies, so an approximate model can be considered for it. Also, Carol is more interested in war movies, action movies, so it is possible to learn a model for this user. For each user, we want to learn an n+1 dimensional vector where n is the number of features that the user's taste is summarized in this vector. In this way, to predict the rating of movie I for user J, we do not need to multiply the entire matrix. This is a Boolean matrix. It shows which user rated which product or not. Y represents the score given by the user to the product. Finally, if this number is small, it means that probably user J is not interested in product I. Bigger number, larger number means more interest. Now, like all machine learning problems, we can reach the goal by optimizing the objective function. We can calculate the errors, the result of subtracting the actual rating given by the user to the product from our prediction. It can represent an error. So again, we use the minimization of the sum of squared errors. This is our goal function. It is easy to use an algorithm like gradient descent to get the best thetas. This learning can be done simultaneously for all users. This formula can be written for each user. Finally, it can gather everyone together. Then minimize this sum. These thetas are the user's taste, but let's go to the first point. Where did the amount of these features come from? So far we have assumed that the experts have provided us with the amount of these numbers, but now in an unsupervised problem we want to get the same features. We have obtained the thetas, we update the x's, then we update the thetas again, and then we update the x's again. That is, we constantly assume that we have one of these two groups and we need to update the other group. Here we have done regularization on x, we can consider and update all x's together. So the idea is very simple. The value of this algorithm was in this part. These repetitions will finally stop somewhere, because this function is a bounded function and reaches a local minimum. After learning this, there is a user and a video. We want to see how much this user is interested in this movie. For this, we use multiplication in terms of normalization. When the thetas are almost zero, then it doesn't matter what the x's are anymore. The result of their multiplication becomes zero. To prevent this from happening, we need to normalize the mean. Mean normalization, I mean. Calculate the average of each row and then subtract the average from all the columns. We arrive at the normalized y matrix. At the beginning, if we want to predict with this, given that we have the average points that users have given to the product, for example, we predicted that user I likes product J by 2.25, and we'll consider this point for it. Okay, and here our discussion in machine learning is over. I hope you could benefit from this educational package. I have tried my best to transfer my knowledge to you, and I am sure about that. If you practice as hard as possible and pay enough and sufficient attention to the Python files and read the PDF files which I provide to you, and watch the videos and read the transcripts, I am sure that you can become one of the machine learning experts, and you can represent a very stunning effect in the world of machine learning from yourselves. I hope you best. Have a nice time. Goodbye.